Hello students, in my last lecture I had given you graphical proof of velocity time relation. Today we shall see graphical proof of position time relation, that is S is equal to ut plus half at square. Once again we shall take help of the same velocity time graph. Suppose this is a velocity time graph in which we take time on x-axis and velocity along y-axis. So suppose this is x-axis, this is y-axis, this is our origin. We take time in second along x-axis and velocity in meter per second along y-axis. Once again, we take equidistant points for different time interval on x-axis. Suppose it is 1, 2, 3, 4, 5, 6, so on. And similarly, the equidistant point on y-axis. Now, suppose once again, like the last situation, initially the object is traveling with uniform initial velocity u. So initial velocity, suppose, is represented by this OA portion of the graph, and in time t, under uniform acceleration, the final velocity of that object becomes v. So this graph AB, this portion represents velocity time graph. Yesterday we had seen that if we draw perpendicular from any point of velocity time graph to x-axis, then the point where it touches gives us time interval. Suppose this is point C and it gives us time interval t. Similarly, if we draw a perpendicular from any point of this velocity time graph to y-axis, that is velocity axis here, then it gives us velocity. So suppose v is the final velocity and here we find any point E. From point A we draw a perpendicular on BC. For the simplicity of our solution, to make our problem easy, we draw a perpendicular from A to BC. Suppose it touches at point T. So once again, consider what is the situation. I had said in my previous lectures also, you can pause video and write all statements and definition easily. So dear students, try to write all statements by pausing video, and I try to make everything clear. So suppose any object starts to move with initial velocity u, and in time t, under uniform acceleration a, its final velocity becomes v. Now in this graph, once again, the initial velocity u is represented by the portion OA of this graph, and yesterday we had seen that what? Once again see, OADC is a rectangle, and in a rectangle opposite sides becomes equal. So here OA is equal to CD, so we can write U is represented by OA, this is equal to CD. Again, this is initial velocity. Initial velocity. Again, the final velocity, which is represented by V. It is given by the portion OE. So here V is equal to OE, and this is equal to how much? BC, because the opposite sides of a rectangle becomes same. Here OEBC is a rectangle whose side OE is equal to BC. So we can write easily OE is equal to BC. Now, what is the time interval here? Here, the time interval T is represented by OC. So, the time taken T is equal to OC, and once again, it is equal to the opposite side of the rectangle, that is, which rectangle is considered here? OADC is a rectangle whose side OC is equal to AD. So we can write here OC is equal to AD. Now, in our previous lecture, we had read clearly what? That the geometrical area between velocity time graph here, the velocity time graph is represented by AB, and which one is the geometrical area? This is the geometrical area between velocity time graph and time axis. So what was our consideration? We had studied that the geometrical area between velocity time graph and time axis gives us distance. So using the same fact, we can write here from our previous knowledge, we can write what? That we know that the geometrical area between velocity time graph and time axis gives us distance. Therefore, what we can write? We can write S is equal to area. How much? Which area? Area OABC. This is equal to area OABC. Now see, this whole area may be divided into two geometrical areas, two geometrical shapes. See, OABC is equal to the area of rectangle OADC, and this plus area of right angle triangle ADB. So we can write it in such a way that this area is equal to area of rectangle C OADC, this plus area of right angled triangle ADB. Now, very beginning, that is from class 5-6, we know what is the formula to find the area of a rectangle. We have read area of rectangle is equal to length into width. So we can write here this area is equal to OC into OA, two sides, or we can write OA into OC. From which property? From commutative property of multiplication. What is commutative property? Recite our previous knowledge. We know that A into B is equal to B into A. Commutative property of product. This property also holds good for addition. So we can write here area of rectangle OADC is equal to OA or plus into OD. So we can write here OA this into OC. This plus. Now, what is the formula of the area of right angle triangle? We know that the formula for the area of right angle triangle is equal to 1/2 into base into height. So what is base of this right angle triangle here? AD. So we can write here this plus 1/2 into base. Base is AD this into height of this right angle triangle, that is BD. This into BD. Now, putting the values from our graph, what is the value of OA? See here, OA is equal to CD is equal to U. This is equal to U into what is the value of OC? COC, here OC is equal to AD is equal to T. So putting the values here. This plus 1 by 2, once again AD. So AD is equal to OC is equal to how much? T here. AD is equal to OC is equal to T. So right here, half into T into BD. Yesterday we had find the value of BD. See, from our yesterday's lesson we shall use here. Yesterday what we had used? We had used BD is equal to AT. See here. Why? Because acceleration is equal to change in velocity by time. From this relation, BD is equal to A into T. So using BD is equal to AT. Here we shall write BD is equal to AT from our previous knowledge. Now with multiplication, what we can write? UT plus half AT square. Therefore we can say S is equal to UT plus half AT square. Proved. Thus we proved graphically position time relation. Dear students, once again I am giving you the same suggestion that these three equations are very important from the point of view of your knowledge, and also it may be a question at different levels. It may be a question at first term, it may be a question of your final examination. What will be the mode of question? So before concluding my lesson today, once again I am giving you homework. What is today's homework? Today's homework is that revise, learn and graphically prove. Prove graphically. Prove graphically position time relation. Position time relation. What is position time relation? That is S is equal to UT plus half AT square. Thank you very much.